Chicka chicka! Physics lesson 11.2 light transmission and Snell's law. Alright, so let's do a quick recap. Remember, light has a set speed, which is 3 times 10 to the 8th, but it can be slowed through more optically dense material, aka if it goes through something that is not a vacuum or air, it's going to slow down. Picture yourself in the hallway. If you go like 5 minutes after class has started, there's probably not a lot of people in the hallway. You can pretty much travel as fast or as slow as you want. If it's right when the bell rings, the hallways get really packed with people and you get slowed down. You cannot move as fast. Same idea with light. We can measure this using something called the index of refraction, where c is the speed of light, which is 3 times 10 to the 8th. N is the material. This is a ratio number. It doesn't have any units. And V is the speed or velocity in the material, so how much it slows down. Interesting point here is this number right here can never be greater than this number right here. Light is set. It cannot go faster than 3 times 10 to the 8th. It's got a speed limit. If it does, all kinds of weird things happen with reality. It'll be mass hysteria. Dogs and cats living together. Who knows? Alright. So, let's practice. Suppose that the speed of light in a newly discovered gem is 1.5 times 10 to the 8th. So that is V. 1.5 times 10 to the 8th. And we need to find the index of refraction. So let's take our speed of light, 3 times 10 to the 8th, and divide it by 0.5 times 10 to the 8th. Be careful. Remember, calculators are dumb and you're smart. If you don't put these in parentheses, depending on what kind of calculator it has, it might try to do the exponents first, which would give you 2 times 10 to the 16th. And that will simply not do. So, remember that when you divide them, they're going to cancel out, and the n will equal 2. Remember, no units. Alright, so remember, whenever a wave travels through a medium, one of two things could happen. One, it could reflect. The other, it could refract. Refraction, again, is bending through the material. It's going to slow down. The velocity is going to change. Reflect is going to bounce back. So reflect, think mirror. Refract, think like going through water. Kind of makes the whatever's in the water look different. One thing that's interesting is that reflection is actually relatively easy. So with reflection, what we get is the angle that is reflected is equal to the angle that it hits it. So whenever we are dealing with reflection or refraction, we have to draw on something called a normal line. And a normal line is just a line that makes a 90-degree angle to our reflecting surface. Right here. This is our reference line. All angles are measured from this. So our incident ray, or our initial ray, is going to have an angle here, and that will be equal to this angle, but they're both referenced from the normal line, not this angle over here. That will not do. No. Okay? Not these angles right here. It has to be to the normal line. You have to have a set reference spot in order to reference it. Now you might not understand why it's over here, but someday you might have a reflecting surface that's curved, and if that's the case, things get a little bit hectic trying to measure angles. Alright, so a couple quick terminology pieces. I won't spend too much time on that since I've already talked about it. Incident ray, that's the light that strikes it. Reflected, that's the light that bounces off. Normal line, you have to draw in a normal line. It's perpendicular, which means it makes a right angle with the reflecting surface. Think the letter T. Incident angle, that's the angle that it hits to the normal line. It has to be from the normal line. Reflected, again, same angle, but bounced off from the normal line. Alright, so picture this. A ray of light hits a plain flat mirror. At what angle would it reflect? Hey, look, it should be exactly the same. Trick being is you have to put in a normal line. So let's put in our ray of lights. let's say it hits, this has angle of 52 degrees, so not quite 52. A little better. Alright, so we need to draw in our normal line. Why is none of this stuff working? Where am I at? There we go. Okay. First of all, we got to draw in a normal line. We'll move this angle out of here first because that's not the right angle. There you go. There's our normal line. Set that right there. 90 from our reflecting surface. Now I'll take this protractor and rotate it around so that it's at 0. There we go. And then, now I can take this and go to 52 degrees. Let me get rid of this. This is not a good one. Delete. There we go. 52 degrees. Alright, so that's our angle of incidence. It's taken from the normal line. We had a reflecting surface. It was right here, but apparently it's attached to the protractor. So when I moved it, it got all haywire, which was not fun. As far as reflection goes, this back at 0. It's going to reflect at that same angle. We'll do it in blue. There. So in other words, this angle and this angle are the same. Yay! Which should be 52 degrees. That is the law of reflection. Alright, I'm going to end it here because I've already been talking for almost 8 minutes, and the next section is going to take a little bit. So I did the same thing in class. It took 2 days to do this instead of just one. Just a lot of information to go over at once. Okay, see you back in a minute.